Okay, here we have a bus traveling at 80 kilometers an hour initially, accelerating for 12 seconds and ending up with a speed of 100 kilometers an hour. And we want to know what the acceleration was. So again, let's write down our given information. We've got 5 variables. I like to write all of them down. It helps to choose the appropriate equation. V initial was 80 kilometers per hour. V final was 100 kilometers per hour. We're looking for acceleration. The time it takes is 12 seconds, and we don't know the bus's displacement. So we're trying to find A. So we're going to avoid equations with D in it. Now before I begin, let's check our units. We've got kilometers an hour and seconds. They don't match. So let's convert all of these to the standard unit, which is meters per second. So to do that, we have to first maybe get rid of the kilometers. So write our conversion factor. And since kilometers is on top, I want to put it on the bottom of my factor, and I want to get meters out of it. There's 1,000 meters in 1 kilometer. So that will get rid of the kilometers. Now I've got meters divided by hours. I want to get rid of the hours. Since hours is initially on the bottom, I want it on top, and I want to get seconds out of it. There's 60 minutes in an hour, 60 seconds in a minute. 60 times 60 is 3,600 seconds in 1 hour. Notice the hours on the top will cancel with the hours on the bottom, and I'm left with meters on top, seconds on the bottom, so we're good to go. So I simply multiply all the tops and divide it by 3,600. So 80 times 1,000 divided by 3,600 will give me 22.2 meters per second. Now similarly with the 100 kilometers an hour, I can convert that as well. So we've got 1,000 meters in 1 kilometer. And then we've got 1 hour is equivalent to 3,600 seconds. And when I work all that through, I get 100 kilometers an hour is equivalent to 27.8 meters per second. So now we know V initial and V final with the appropriate units. Now we can begin our calculation. So we want to avoid equations with D in them. And the one formula that doesn't have D in it is V final is V initial plus AT. Now we're trying to solve for A, so we can either do that now and do the algebra or do it at the end. It actually doesn't make any difference. Let's maybe do the algebra now as a little bit of practice. So to get A by itself, let's get rid of the addition and subtraction first. So subtract a VO from both sides, which is the same as adding a negative VO to both sides. So those are gone. Now let's rewrite this so that it looks a little more familiar. That's V final minus V initial on the left equals acceleration times time. And I want to get A by itself, so I've got to divide both sides by T. But I have to divide everything by T. So my acceleration is V final minus V initial over T. So let's plug in the numbers. Acceleration, V final minus V initial all divided by time. And when I do the calculation, I end up with a positive acceleration of 0.47.